Hi everyone. By this stage of today's lesson, you should have already seen two examples of particle behaviours in expansion. You should have seen the balloon expand and you should have seen the metal ball expand in both experiments. If you haven't done that, you need to go back to the written instructions in this assignment and follow those steps to complete page 18. Having looked at the two experiments beforehand, hopefully you had good fun trying to work with your balloon and getting it to expand with the hot water. And on page 18, you were asked to complete practical task A, and you're asked to place the balloon over the neck of an empty bottle, place the bottle in a container of very warm water or even boiling water if you'd watched that first video, and record any observations. And it was really important that you were safe there so that you didn't get burnt. And then you had to take the bottle and put it in another container which had very cold water in it and see what had happened. And you should have written your observations down in this section that said observations. If you haven't done that, make sure you do that now before you go any further and pause this video. If you did manage to get the practical done, or indeed you watched the first video that was attached to the assignment, you should have written down a set of observations here. And if I was doing this, what I would write down is this. The balloon inflates in the hot water and then deflates again in the cold water. And hopefully you saw that happen. You saw the air particles in the balloon expand when they were warmed up, and you saw them then contract when they got cold. And these are the theories that we're looking at, these scientific explanations. Looking at practical task B, this is one you couldn't do at home because you needed the Bunsen burner. So hopefully you watched the second video, and you only had to watch up until 4 minutes. We were watching the first practical that was done there. You could see that the Bunsen burner was lit and that at the very start the ball passed through the ring very easily. But once the ball was heated up, you should have noticed something happen. And what you noticed, those observations, should have been written into the second section for observations on page 18. Hopefully you noticed the same thing as me. And I wrote then, when the ball is heated, it will not pass through the hoop. When the ball cools, it will pass through the hoop again. Make sure you have these observations written in before you go any further today. Look to the top of page 19, you will see this diagram. And this diagram shows you how the particles are arranged in a solid when it's both cold and then when it's been heated up and it's hot. Now you should already know that particles in a solid are arranged in a regular organized pattern, and they're very close together. And they're so close in a solid that they don't have the freedom to just move around as they please. But they do have enough space that they can vibrate a little bit. Remember in the video, they were described as eggs in a box. And eggs in a box are in their set position. They can't move from their position, but they can vibrate a little bit. Now, when it's cold, imagine the eggs only being shaken a little. They just vibrate a little. But when particles are heated up, they gain energy. And you know yourself, when you gain energy, you have the ability to move around a lot more. And when these particles gain energy, then what they can do is they can vibrate a lot more and a lot more dramatically. And so you can see with the hot diagram here, they have more space around them. The particles don't change size, if you notice. They're the same size, but the distance between them increases. And that's because they gained more energy with the heat added, and then they vibrated more and they were able to move further apart. But remember, they do not change size themselves. So what we're going to write just below that diagram is these things that we've noticed that happen when we heat up particles. So let's write this down. When you add heat is written for you already, and you should see you've got 5 lines where you can write the remaining information. So make sure you write it down as we go along and pause if you need to, if I'm reading too quickly. So when you add heat, number 1, the first thing that happens is the particles have more energy. You heat them up and they gain heat energy. And remember in year 8, we learnt that energy comes in lots of different forms. So they take in that heat energy and they change that to kinetic energy that lets them vibrate a lot more and a lot more dramatically. The second thing that happens then is that the particles vibrate more, and we've just said why they do that. Because they've gained the heat energy, they change that to kinetic energy, and they vibrate more. And what happens as a result of that then is that they move further apart. Imagine you were all standing in a row beside each other, shoulder to shoulder, and one of you started to kind of move from side to side a little bit. You would kind of nudge the people beside you. But if you started to really sway from side to side really dramatically, you would cause a lot more movement. And to be honest, the people beside you would probably get fed up and would move further away. And the same happens with these particles. They vibrate more and they move further apart. The fourth thing that happens is the object then gets bigger. Because the particles have moved further apart, they're taking up more space. And so that whole object gets bigger. And we saw that with the balloon. The balloon got bigger as the particles gained energy and moved further apart. The same with the ball. It got bigger because it no longer fitted through the ring. Because the particles gained energy, they vibrated more and they moved apart. But the final thing is, what you really need to remember, do not get confused. The particles do not change size. Remember in that previous slide, or on the picture just in your book there, the particles are the same size whether they're hot or they're cold. It's the total object that changes size, not the particles. They just vibrate more. We then need to fill in this sentence, and if you're not finished writing down those 5 points, go back in the video and write them down. It's really important that you have them in your notes. But let's look, once you've finished that, at this sentence just below. And it says, when a substance cools, the particles lose, causing them to vibrate less and move more slowly. The particles move together. This is known as, hopefully you can fill these in. I gave you a clue for the last word at the very start of the video, and I wonder, can you remember what I described it as? Write these in, pause the video, and when you're finished, hit play again and I'll go through the answers. When a substance cools, the particles lose energy. Well done to those of you who got that. So they lose energy, causing them to vibrate less and move more slowly. So just the reverse of before. The particles move closer together because they're vibrating less. They take up less space. This is known as contraction, or you could say contracting. They get smaller, they contract. Well done if you got them. Once this video finishes and you've got all the information copied up on page 18 and 19 so far, what I want you to do is go back to the main assignment in Google Classroom and play this final video called Thermal Expansion: Why Are Small Gaps Left in Between Rails? And hopefully you will notice along a railway track, the rail on one side is not joined side by side. There's a little gap between them, and there's a reason for that. So it's really important that you watch that video, and it might give you some other examples as well. Once you've the video watched, then what I want you to do is complete the examples of expansion at the bottom of page 19. So you must fill in the spaces on the bottom of page 19 once you've finished that video. When you've got that done, the final thing then you have to do in terms of work today is that you must complete the homework task at the top of page 20. Once you have those two activities finished, or those two tasks finished, then what you need to do is submit these two tasks to Google Classroom and do it either as a PDF or as pictures inserted into a Google Doc. And you will see the Google Docs assigned to this assignment. You can use them, or remember, you can do it as a PDF because it's much quicker for you in the long run in terms of waiting for it to submit. So hopefully you're all clear on what you're doing today. If you've any problems, don't be afraid to get in touch. I'll try and be near the laptop so I can get back to you as quickly as possible. But this should give you a great insight into expansion, which is really useful in science and really important for you to know. I'm missing seeing all your faces and hearing all your jokes and all your crack, but I hope you're keeping really well, and I'll chat to you soon. Bye now, folks.